Good evening, everyone. This is Colonel B.D. Singh once again in front of you. And today I'm here to let you know about microphones. Now, most of you must be wondering why telling us about microphones we have been using practically in everyday life. No, the whole idea over here is to give you a very, very deep insight into the functioning of microphones, what these microphones are, what are the various types, and how you can use them effectively. So, kind of a technical tutorial, but I have tried to make it as simple as possible. So, it's a introduction to microphone, kind of a small tutorial for all of you. So, let's look at the basic definition. What is a microphone? It is a kind of a transducer which converts one form of energy into the other form of energy. That is sound energy into electrical energy. Basically, two types of microphones are there: dynamic microphones and condenser microphone. While dynamic microphones do not require any external power to be energized, these dynamic microphones have got a magnetic diaphragm, and they only react to strong sounds. That means if there is a faint sound, then dynamic mics don't catch them. Dynamic microphones are rugged, short range, and with low sensitivity. The very fact that they cannot react to strong sounds, their sensitivity is low. Whereas condenser microphones, they don't create electricity. They use external electricity. That's to energize a condenser microphone, you require an external source of energy. So there's an international standard for this, which is basically 48 volt DC, which is supplied to the condenser microphone in order to make it functional. They are very sensitive, greater range, and of course they are fragile. They're expensive also. If you drop, a condenser microphone, there are chances that you will never be able to use them again. So one has to be very, very careful, when handling condenser microphones. And condenser microphones are very sensitive to sharp sounds, even if they are coming from distance. So in other words, their sensitivity is high. Diagrammatically, I mean, all of you are basic students of science, so you will understand. Look at the diagram of dynamic microphone. Sound waves are coming from left side. That is being shown a pink kind of a thing, arrow. Then there is a diaphragm. They hit the diaphragm, a very thin membrane made of plastic or rubber, and which is actually attached to a moving coil. That moving coil, is moving inside a magnet. So its movement, to and fro movement, produces a kind of a electrical signal. So your sound waves are converted into electrical signals, and then they go for amplification. Whereas when we talk about condenser microphone, in a condenser microphone, there is a back plate, which is a charged plate. It has got some electricity, and sound waves hit the diaphragm, and the diaphragm then it vibrates, and the tiny space between the back plate and the diaphragm, it varies. So it's a kind of a condenser. So this variation in this causes output electrical signals, and that's how the electrical signals go out from here. And this condenser microphone is very, very sensitive. Why it is sensitive? Because it can catch distant faint sounds, and it is fragile also because of its the way it has been manufactured. So one has to handle a condenser microphone very carefully. And there are a number of, like, you have got handheld microphones, then you have got shotgun microphones, which we often see with the journalists. I mean, when you see in a TV, you find that kind of a longish, microphone, which is there attached to the camera, or sometimes to a boom stand. So these microphones are highly directional. They catch sound only from the front side. Then you have got lavalier or lav microphones, which are known as collar microphones also. You will find that most of the speakers on the stage, they put on this clip on the collar, and then they speak, so that they don't have to hold a microphone. So it's a hand-free kind of a thing. Then we have got pressure zone microphones. Some of you must have seen, not all of you, because pressure zone microphones are generally kept on a flat surface like table where a conference is being held. The beauty is that it catches sound from all the directions. And there are a number of speakers, either they are sitting in a circular fashion or perhaps in a rectangular fashion. And this microphone is placed flat on the table. So it catches sound from all the directions. So very, very specific use. We don't use it for music. Now, picking up sound has got a little bit of geometry, sound can be picked up from all the directions, which is known as 360-degree. And the microphones are built in such a way that some of them are omnidirectional. That means they catch sound from all the directions. Some of them catch from a particular direction. So it will be clear to you, once you see the pickup patterns. So omnidirectional microphones, obviously, as the name suggests, its pickup is 360-degree. The speaker may be on, any side. So right from 0, 90-degree, 180-degree, 270-degree, anywhere. Whereas in a cardioid, which is heart-shaped kind of a pattern, why this pattern is heart-shaped? Because this is the pattern in which sound is picked up by the microphone. So you'll find that maximum pickup is from the front side, and pickup becomes lesser as you go on both sides. So this forms a kind of a cardioid pattern. Pattern means it is an imaginary thing, but this pattern shows that it is the pickup zone of a microphone. Then you have got unidirectional or hypercardioid. It picks up forward, like shotgun type of microphones, which you find, these TV journalists are holding in their hands. Long microphones, and so they generally, most of the sound is caught by the front side and very less sound from behind. You see this kind of a mic every day. Then you have got bidirectional mics. That bidirectional means in a figure of 8 pattern, equally from both sides. So like there is a microphone, and then there are 2 speakers facing each other. And so microphone will take care of both sides. And that's how the pickup pattern is like figure of 8. Now, how do we connect microphone to the system or to the preamplifier? By way of various types of connectors. These connectors are internationally universal. Like XLR is a 3-pin connector. This 3-pin connector, the female side of this connector goes into the microphone, and male side of this connector goes into the amplifier. So this is known as XLR, 3-pin connector. Most of the microphones, professional microphones, are using this. The beauty is that this reduces noise. There is a line noise, whenever you're connecting your microphone to the amplifier or preamplifier. So cables are quite amenable to certain types of noises. So noise cancellation takes place, and this is a very, very high grade connector, XLR or 3-pin connector. Then we have got mic connector as 1/4 inch or 1/4 inch. It is also called a headphone connector. I'm sure you have seen this in everyday life. So certain microphones have on the other side, they have got headphone connector, which does not have 3 pins. It has got just 2 kind of a thing, and it goes. Then we have got mini connector, which we often use in the in the tabs and in certain old types of Androids, where a very, very tiny hole is there for your headphone. And so microphones also use this kind of a connector, which is known as mini connector. 1/8 inch, that is the diameter. Now there are certain tips on purchase of microphones, because there is a plethora of microphones in the market, and you get confused which type of a microphone is suitable for you. So you can get quickly overwhelmed when you start searching for a microphone for the very first time. So you need certain parameters so that you can choose the right kind of a microphone. The first thing is to consider what will be the main use of your microphone. Is it to record vocals and guitars? That means if you're a singer, then your requirement is different. And do you just require this microphone to basically amplify the sound of amplifier? Maybe you want to record a piano which you have in your house, and you just want to hang, a microphone near the piano. Or do you want one that can do all purpose? So these questions should guide you towards your first narrowing choice regarding coloration and the frequency response. Do I need a bright neutral or a dark mic? So this you have to decide. You can find lists of these online microphones to help you. In fact, you will find most of these microphones from Amazon. I have purchased all my microphones for my studio from Amazon, and they are highly reliable. And they also give the technical background, various types of condenser microphones and dynamic microphones. And there are famous companies for this. Just keep in your mind, Shure is one of them. SHURE, Shure. Then Shure is an American company. Then Sennheiser is a German company, basically. And there are a number of other companies, like Sony also makes, but Sony makes microphones which are very cheap and basically for home purposes. And they're, of course, they're not costly at all. Microphones may cost you very dear also. I'll just give you an idea. There are microphones, professional microphones, which may cost up to 1 lakh rupees per microphone. But for day-to-day purpose, like the microphone which I'm using right now, it costs about $3,000, and it's fairly okay. It's a condenser microphone. And as a thumb rule, condenser microphones are slightly more expensive than the dynamic microphones. Dynamic microphones you can get for as less as $900 or 1,000 rupees. But then again, it depends. Are you a singer, an orator, or perhaps an instrumentalist who just wants to amplify sound from his amplifier by putting a microphone near that amplifier, and that's how you achieve your things. So these same questions will help you determine if you need to be able to change the pickup patterns on the mic. If you're recording piano, you need something that can act more like a room microphone, unless you plan on getting two and setting them in a stereo pattern. Sometimes we want to pick up the sound from the source to give it a stereo kind of effect. In such cases, you require 2 or maybe 3 microphones. Maybe you want to record vocal duets, but you can only afford 1 mic, in which case you would like to have a mic which allows 2 singers, on standing in front of each other, so that the microphone catches sound from both sides. This is imaginary, how you can imagine a figure of 8 sound. Figure of microphone is there, it's there vertically, and on both sides, it is catching the sound. Sound source is on both sides. So this is how it is making a figure of 8 pattern. And one last thing which you have to consider, when you're purchasing a mic, whether you want a condenser mic or a dynamic mic. And this will be based actually on 2 things. The first, in which environment you are going to use it. If you're taking it on stage, you would want a dynamic. It's not so sensitive, and it's picking up sound of everything else going around, and you in the crowd. For the studio, I definitely recommend a condenser kind of a mic, because condenser mics are ideally suited for studio sessions like I'm using here. It's it's good for singing also, and if I speak into the mic very softly, it will catch that also. This shortcoming is there in dynamic mic. The dynamic mics cannot take care of such varying degree of sounds. But the thing is, it also depends on your pocket. If you want to have a reasonably decent microphone within the budget, then by all means go in for a dynamic microphone. And these are available off the shelf. You can simply place an order on Amazon and order. Like I have been using for most of the time. Shure mic model is SM57. This is a universally accepted microphone for the speech, for singing, even for recording, something live, like you're playing a guitar or something. SM57. Just remember this model number. And all over the world, I think this is the most popular microphone, dynamic microphone. Now, pay attention to this particular graph, very, very self-explanatory. These are all fundamental frequencies which are generated by human voice and by various types of instruments. And as you know, that frequencies are basically, they are starting from low frequency and going high pitch. On the right side is high pitch, and starting from 30 hertz, 50 hertz, or hertz means cycles, and goes right up to 16 kilohertz. The ability of human ears is basically confined within the range of 80 hertz and about 15 kilohertz easily. Some people who become hard of hearing, this happens with people who are working in a noisy environment, in an industry where a lot of noise is being made, or a Fauji like me, keep hearing the sound of blast from the guns. So that also affects your eardrums, and they become lesser, because your eardrums are the best example of natural microphones, because they pick up sound and then they convert it into electrical energy which goes into your brains, and you understand. So like for example, piano. If you look at piano, its fundamental frequency is very, very low. Black mein dikhai de raha hai upar aapko, and it goes right up to 5 kilohertz. Whereas the harmonics, the secondary frequencies which are generated by piano, may go right up to about 12 kilohertz. Then I'm just randomly, picking up like sound of a flute. It typically starts at 300 cycles and goes right up to about 2000 cycles. But its harmonics may go even further. Now, if you come down below, male voice, like I'm speaking to you. So male voice may start, as low as 100 cycles and go right up to 900, or sometimes even up to 1 kilohertz. While a female voice is slightly high, it is set at a higher pitch. Nature has made their vocal cords like that. So a female voice will have a low of about 300 hertz and a high of about 3 kilohertz. There's a Lata Mangeshkar. She had the ability to sing right up to 4th octave, very high pitch. So when we talk about low pitch and high pitch, we are actually talking about the frequencies. So low frequencies means low pitch, higher frequencies means higher pitch. So this is a rough kind of a graphical representation. There are a number of instruments, but this basically gives us an idea. Like I as a music composer and as a sound engineer, this graph comes to me very handy, because when I'm setting up the various input channels on my mixer, and I've connected microphones into that, so I choose the right kind of microphone and for different types of instruments. So that I capture things in their natural form. This is very, very important. There's something known as a frequency response graph. When you buy a microphone, when you unbox a microphone, you will find that there are certain technical literature with that. So the most important technical literature is known as FR graph, or frequency response graph. It basically tells you the ability of the microphone, how sensitive the microphone is as far as certain frequency ranges are concerned. So if you look at this graph very carefully, on the x-axis, it shows you the frequencies. On the vertical or the y-axis, it shows you the sensitivity, which is shown in terms of decibels. Decibel sounds, everyone knows. I mean, if you hear something which is more than 80 decibels, it may damage your ears also. That is a very universal kind of a law. That's why the Ministry of Environment has also set a particular limit for playing loudspeaker and DJs and things like that. Anything which goes beyond 80 decibels is bad for your ears if you're in the near vicinity. So, like in a microphone, its sensitivity will be shown in the form of frequency response graph. So you will be able to judge which kind of a microphone is suitable for your purpose. If you are a guitarist, you are a vocalist, or you are simply an orator. Now, to make it a little more interesting, I have culled out two videos from Shure company, and these videos are available on Shure.com. I told you Shure is the company which manufactures microphones, and this is purely for academic interest. So there are two short movies which will basically make all these ideas very, very clear in your mind. So here it goes.
A microphone's primary purpose is to convert acoustic energy, sound, into electrical energy, a signal that can be amplified, recorded, or transmitted. Because the microphone is the first link in the audio chain, it's important to choose the right microphone for the job. When choosing a microphone, you need to consider the desired sound source, whatever the mic is supposed to pick up, and the equipment that the microphone will connect to. The microphone needs to be able to handle the loudness and frequency range of the voice or instrument that you're miking. If it doesn't, your audio might have noticeable hiss, distortion, or voices and instruments might not sound natural. The microphone also needs to be compatible with both the physical connections and the electrical characteristics of the audio mixer, recorder, or computer that it will connect to. If it isn't, you might have problems with noise, low level, or no audio at all. To know how a microphone will work for a particular purpose, you need to check its technical specifications. These fall into 4 general categories. In this segment, we'll discuss the operating principle. The operating principle describes the type of transducer that the microphone uses to convert sound into an electrical signal. The most common transducer types are dynamic and condenser. In a dynamic microphone, sound waves strike a thin plastic diaphragm and cause it to vibrate. A coil of wire attached to the back of the diaphragm vibrates along with it. As the coil moves back and forth, it passes through a magnetic field created by a magnet, which generates an electrical signal that corresponds to the sound. Dynamic microphones can handle even the loudest sounds without overloading. But this also means that they're not well suited to distant miking of quiet sources. Because the sound waves have to move the mass of the diaphragm and the voice coil, they usually have limited high-frequency detail, so they're better for vocals or horns than for stringed instruments. The size of the magnet makes it difficult to make a dynamic mic very small, which can limit your mounting options. In a condenser microphone, sound waves also strike a diaphragm and cause it to vibrate. The diaphragm is mounted just in front of an electrically charged plate. As the diaphragm moves back and forth, it changes the electric field between the diaphragm and plate, which generates an electrical signal that corresponds to the sound. Since there is no voice coil in a condenser mic, the sound waves only have to move the diaphragm. This gives condenser mics better high-frequency detail than dynamics. This makes them ideal for miking stringed instruments, percussion, piano, or subtle vocals. Condenser mics usually have higher output than dynamics, so they're good for distant or quiet sources. Since there's no magnet in a condenser mic, they can be made extremely small, which makes it easier to mount them in tight spots and make the mic less visible. Condenser microphones have internal circuitry that requires power to operate. Usually, phantom power is supplied through the microphone cable from the mixer or recorder. Some condenser microphones can run on an internal battery, but that's less common. Unlike dynamic mics, the electronics in a condenser mic can overload when exposed to very loud sounds. Make sure that the condenser mic you're using can handle the sound levels that the source can be expected to produce. By understanding microphone characteristics like operating principle, you'll be able to choose the best mic for any application and get better results when recording or using a sound system. In part 2 of this series, we'll explain microphone frequency response. To hear samples of how different microphones sound, visit the Shure Mic Listening Lab at shure.com.
Now this short video must have clarified a lot many doubts in your mind about microphones. And some of you who are interested in more details, you can always visit the site of shure.com and get more details about it. But as a thumb rule, you have to remember that condenser microphones are very good for high-pitched instruments. And while dynamic microphones can take care, they are actually meant for general purpose. So in studios, you will find that singers, 100%, they use condenser microphones whenever professional recordings are being made. They don't use dynamic microphones. So dynamic microphones, because they're cheap, easily available in the market, and easy to use also. And plus, if you drop them, not much damage happens to them. Which in case of condenser microphone, you can damage it if you drop it. So that's how you have to sort of keep these things in your mind. For which purpose are you choosing a dynamic microphone or a condenser microphone? And what kind of directionality are you looking into? Are there two people and just one microphone, or you are using for the vocals, or you using for the instruments, and so on. So now let's have a look at the second video, which gives you a little more insight into the microphones.
In part 1 of this series, we covered the most common operating principles that microphones use to convert sound into an electrical signal. In this segment, we'll discuss frequency response. The sound of a microphone is illustrated by its frequency response curve. The frequency response defines the range of sound that the mic can reproduce and how sensitive it is within that range. A microphone with flat response is equally sensitive to all frequencies, so it reproduces voices and instruments with little or no coloration or variation from the original sound. Flat response mics are a good choice for miking acoustic instruments, vocal groups, and orchestras. A microphone with shaped response is more sensitive to some frequency ranges than others. A mic with increased sensitivity in the upper mid-range adds clarity to vocals and also works well on instruments like guitar amplifiers or drums. A mic with decreased sensitivity to low frequencies reduces pickup of room noise and vibration and counteracts the buildup of bass that can occur when the mic is used very close to the source, which is called proximity effect. The choice of frequency response for miking a particular voice or instrument is very subjective. In general, however, microphones with shaped response work better than flat response mics for vocals. Here's how a vocal sounds on a Shure SM81, which has a very flat frequency response.
For I'll be here in sunshine or in shadow. Oh, Danny boy, I love you so.
Here's the same vocal recorded with a Shure KSM42, which has a shaped response.
For I'll be here in sunshine or in shadow. Oh, Danny boy, I love you so.
Some microphones allow the frequency response to be adjusted to match different sound sources or recording conditions. The most common is a low frequency roll-off control. In the flat position, the mic picks up low frequencies normally. In the roll-off position, the mic's sensitivity to low frequency sound is reduced. By understanding microphone characteristics like frequency response, you'll be able to choose the best mic for any application and get better results when recording or using a sound system. In part 3 of this series, we'll explain microphone polar patterns. To hear samples of how different microphones sound, visit the Shure Mic Listening Lab at shure.com.
So folks, at the second part, you have seen a little more detail about the microphone. And basically with each, I have divided my session into 2 parts. The second part of this microphone will happen perhaps after a few days, in which we'll get into more details, technical details, but I'll simplify them for you. In that, I will also be telling you about what kind of ideal distance to be kept. Some people have a habit, you must have seen some singers or orators. They're so keen, while they're holding the mic, it looks as if they are going to eat the microphone. So you have to have a respectable distance between your lips and the microphone in order to get the best response. If you're too close to the mic, you will be basically producing certain undesirable noises because of the a sudden attack in the air. Because when we are speaking, what is happening? We are moving the air. This sound energy is movement of air, and it is hitting the diaphragm. So some people who are very loud, when they speak, they're naturally very loud. Most of the teachers, you will find that they're very loud. So for them, it's advisable to keep distance from the mic as far as possible, but there is always an optimum distance. And generally, for good response, you can always keep your mouth from the microphone about 6 inches away, 6 inches to 1 foot. If it is more than that, then of course you have to make a lot of effort. You really have to shout, which you don't want. So I think 6 inches is good enough as a thumb rule to get the best effect. And the same thing goes for the condenser mic also. You must have seen in your laptops, you find a tiny hole, on top of the screen. That tiny hole is basically a condenser mic, because condenser mic, owing to its construction, it can be made very, very miniature. In fact, even in the espionage missions, people are using condenser microphones, which can pick up a very, very faint sound, which normally human ears cannot pick up. And that's why, when you're having your Skype or any other kind of, video conferencing, you don't really need an external microphone. You have a condenser microphone, which has been built into the system. Right, it is right next to the, that lens, the camera lens, which is there on your laptop. And this tiny hole has got a small little condenser microphone. Even if you whisper into it, it will record. That's the beauty. So this basically brings me to the end of part 1. So picture abhi khatam nahi hue mere dost.